What's going on, everybody? Welcome back to my YouTube channel. Well, we have this question on the board which says find the value of x for which x to the power 3 plus x to the power 2 is equal to 4 over 27. Well, our first step towards solving this question will be for us to cross multiply. So on cross multiplying, I'm going to be having 27 times x to the power 3 plus x to the power 2 equal to 4. Now let's go ahead and expand this bracket. So expanding, we have 27 x to the power 3 plus 27 x to the power 2 equal to 4. Now let's focus on this 27. 27 can be written as 3 to the power of 3. Then I have x to the power 3 plus, this is 27, which can be written as 3 to the power of 3. Now times x to the power 2 equal to 4. Now since 3 and x are having the same power, we can go ahead and group them together. So we have 3x raised to the power of 3 plus, now I'm going to be simplifying this 3 to the power 3 such that it has a power of 2, just like this x here. So this 3 to the power 3 can be written from indices as 3 times 3 to the power of 2. Remember, the power of this 3 is 1, and from indices, the base are the same. We can take one of it, 3, add the powers, 1 plus 2 to give 3. So this expression here and this expression here are actually the same thing. So x to the power 2 equal to 4. Now notice that these 3 and x are having the same powers, so we can go ahead and group them just like this. So this becomes 3x to the power of 3 plus 3, then 3x to the power of 2. So I've actually grouped this equal to 4. Now I have 3x here, I also have 3x. So we can therefore make a substitution by saying let p be equal to 3x. That means wherever I see 3x, I'm going to be putting p there. So let's go ahead and do that. So this is 3x, so I'm going to be putting p raised to the power of 3 plus 3p to the power of 2 equal to 4. Now let's move this 4 to the left hand side so that we have p to the power 3 plus 3p to the power 2. As 4 crosses to the left, it becomes minus 4 equal to 0. Now we have a cubic equation. We're going to be using the factor theorem to solve this cubic equation. Well, p equal to 1 is a factor. When I substitute 1 into this expression, I'm going to be having 0. So p minus 1 is a factor. So let's write it there. P minus 1 is a factor. Now how do we get the other factor? Well, I'm going to be using this method. Write the coefficient of this equation. The coefficient of p to the power 3 is 1. The coefficient of p to the power 2 is 3. I'm supposed to have p, but it's not there, so the coefficient is 0. Now the coefficient of the constant is negative 4. I can go ahead and write this and drop down this first coefficient, which is the leading coefficient. I'm going to be dropping this down. So since I have 1 here, I'll drop it here, 1. Now I'm going to be using what is here to multiply this. So 1 times 1 is 1. So let's add up. 3 plus 1, that's 4. Now 4 times 1 is 4. Now let's put a 4 here. So 0 plus 4 is 4. Now again, 4 times 1 is 4. So I'm going to be writing the 4 here. Now add up. We have minus 4 plus 4, that's 0. So this is our quadratic equation. This becomes p to the power 2. Remember, these are just the coefficient. P to the power 2 plus 4p plus 4 equal to 0. So this is just the quadratic equation from here. So let's write it here. We have p squared plus 4p plus 4 as the other factor equal to 0. Now remember, we said this is a quadratic expression which can further be factorized. So we have p minus 1. Now on factorizing this, you notice that p plus 2 is a factor. So we have p plus 2. And there are two of them, so we can go ahead and square this since there are two of them. So the factorization of this quadratic equation yields this equal to 0. So we have two cases. We have p minus 1 times p plus 2 to the power of 2. Let's go ahead and solve this in the next slide. Now from the first case, we have p minus 1 to be equal to 0. Or from the second case, we have p plus 2 to be equal to 0. Remember, there are two of these, so this one is happening twice. So from here, we have p to be equal to 1. And from this other case, we have p to be equal to negative 2. Remember what we said? We said let 3x be equal to p, right? From our substitution. So let's go ahead and put the value of p using the first case first. So let me write case 1. So for the first case, this is 3x equal to p for the first case is 1, so equal to 1. So the value of x will be equal to 1 all over 3. Now let's go ahead and solve this second case. So for case 2, using the same expression that we used to substitute, 3x equal to p. Now I'm going to be substituting negative 2 for p. So 3x will be equal to negative 2. And now making x the subject, x becomes negative 2 over 3. Remember, we said this happens twice, right? So this is twice happening. But we're going to be picking 1 because x is x, right? Very good. So these are the two values for x, or 3 values for x, if we may say. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.